Hi, I'm Edmund, and I'm the third member of this group, and I'll be doing section C. The first question is, compare the Simpson's rule with the trapezoidal rule. By comparing Simpson's rule with trapezoidal rule, we found out that the Simpson's rule requires an even number of strips, while the trapezoidal rule can use any number of strips in order to do the formula. And for the second part, we found out that the Simpson's rule is more complex compared to the trapezoidal rule. The next question, discuss its advantage and disadvantage. The disadvantage of trapezoidal rule. When the curve is going up, and by using the trapezoidal rule, you will divide it into trapezium, and therefore there will be an underestimate of the curve, whereby when the curve is going up and we will be using trapezoidal rule and divide it into a trapezium, there will be an overestimate, and this is the disadvantage of trapezoidal rule. As for the Simpson's rule, there won't be any underestimate or any overestimate of the values for this curve. As for now, I'll be doing tutorial 4 question. When a battery is applied to the sending end of a long telegraph line, the growth of received current at 5 ms interval is given by this graph. Step 1. We apply root mean square value rule into this question, and therefore you will form this equation: A RMS equal to square root 1 over B minus A integrate BA A square dt. That time equal to T and current equal to A. We will be using the Simpson's rule on this part of the equation. Because we need an A square, we need to turn all the A's value into the A square values. Therefore, we applied the formula of the Simpson's rule. H over 3 y0 plus y8 plus 4 bracket y1 plus y3 plus y5 plus y7 close bracket plus 2 y2 plus y4 plus y6 close bracket. How do we get the value H? We get it from here. Current end of 5 milliseconds intervals. And therefore, we will be getting the value 8723.333. And now we will be applying the whole formula, and by subbing in the value, B is equal to 40, which came from here, and A is equal to 0, which came from here, and we will be subbing this, which we found 8723.333, and thus we will be getting this value, which is the current RMS.